Wow, look at that. What a hairball. But it's a quotient, so the quotient rule should work on it. Let's get it prettied up before we get started. The numerator is x to the second power third root, so you can write it as x to the 2/3. Then down here we have 2x to the 1/2. Okay, that's better. Now the quotient rule starts. Bottom, 2x to the 1/2. Derivative of the top would be, we multiply by the power, 2/3 x to the 2/3 minus 3/3 is minus 1/3. Bottom d top minus top d bottom. 1/2 times 2 is 1, x to the 1/2 minus 2/2 minus 1/2. So bottom d top minus top d bottom all over, and when we do the bottom squared we get 2 squared, which is 4, and root x times root x, which is simply x. Okay, so the denominator's not too bad. The numerator is very bad indeed. And now we have to multiply these together, which is going to be interesting. When we multiply these, we're going to be adding exponents, which means, because we're adding fractions, we need a common denominator. So I'm not going to erase these, but I'm going to put the common denominator versions right above them. 1/2 is 3/6. 1/3 is 2/6. 2/3 is 4/6. 1/2 is, I'll put the minus signs on too, minus 3/6. Okay, so these are what we're going to be using when we add powers, which is coming up right now. First term, 2 times 2/3 is 4/3. X to the 3/6 plus minus 2/6 is 1/6. Then we get minus x to the 4/6 plus minus 3/6 is 1/6. Like terms. Nice. Okay, so if we subtract these, we have 4/3 minus, the coefficient here is 1. Think of it as 3/3. 4/3 minus 3/3 is 1/3 x to the 1/6 all over 4x. You could stop there, I guess. It bugs me a little bit having this fraction in the numerator, and so what I would suggest here is multiply the top and the bottom by 3. If you do that, you get 3 times this and 3 times this, and your new improved version now is x to the 1/6, because the 3 and the 1/3 cancel, over 12x. I think that's a small step forward, but I would do that every time.